Good morning, everyone, or good afternoon or evening, depending on where you're watching from. My name is Miranda Smith, and I'll be hosting today's breakout session on pig management. So we have two excellent speakers lined up, the first one being Dr. Hyatt Frobose. So Hyatt serves as the U.S. Commercial Director and Nutritionist for Jyga Technologies, which is a Quebec-based company producing Gestel brand precision feeding systems for the swine industry. So Hyatt specializes in assisting swine producers with group housing solutions and nutritional programs to optimize performance and welfare of gestating and lactating sows in commercial environments. So in 2015, Dr. Frobose completed his doctorate degree in swine nutrition and management at Kansas State University, where he authored or co-authored 8 referee journal articles and 22 abstracts. So this research focused on nutrition and reproduction interactions in gestating and lactating sows and the effects on mycotoxins on pig growth. So Hyatt also served as a 2011 US Fulbright scholar to Australia, and he coached the Kansas State University Collegiate Livestock Judging Team from 2010 to 2014. So Hyatt is based out of Greeley, Kansas, where he, his wife Brandy, and daughter Oakley own and operate a seedstock Gelbvieh cow-calf operation. So Hyatt, please take it away.
Good morning, and pleasure to be here this morning speaking with you all about precision feeding, and look forward to the discussion afterwards. Today we're going to be talking about precision feeding in sows, gilts, and growing pigs. We're going to be talking about how we take it from an idea and a principle into execution and practice in farm. There has been a lot of advances in research relating to individual nutrient requirements of growing pigs and sows in recent years. However, swine nutritionists at the farm level have traditionally been limited by the infrastructure, logistics, and labor constraints, both within and between farms, which unfortunately have forced a lot of systems to apply a one-size-fits-all feeding approach for most production stages. However, new feeding technologies that have entered the market in recent years may allow nutritionists to circumvent some of these previous limitations and allow them to utilize precision feeding concepts, which we know to be valuable from a biological and physiological standpoint. Some of these different concepts that we'll talk about include diet blending, dosing microingredients, machine learning, and timed feed delivery to match the daily needs of the individual pig more closely. While many swine industry professionals continue to cling to what I would say is a traditional dogma of producers' limitations on feeding strategies in previous decades, we're starting to see more and more producers and progressive production systems that utilize some of these precision feeding concepts on farm in order to improve efficiencies and optimize productivity in production systems. I'd like to start by talking about gestating sows. And on the precision feeding side for gestating sows, there are several topics that often come up. One of those is parity-specific feeding. I'm going to go into that in more detail, as well as phase feeding in gestation, and some opportunities that exist with top dressing specific feed additives. I'll go into those in more detail on some future slides, but wanted to cover this at first. I think to set up the background, though, I really appreciate some of the work done by Yves Dormad's group at INRA that really have helped demonstrate the individual variability of nutrient requirements within a gestating sow population, both within a farm and between farms. So taking data from 2,500 sows on a commercial farm, they were actually able to plot the metabolizable energy requirements and SID lysine requirements per sow on a basis relating to their live weight at mating. And you can see from this slide, there's a large variation around the metabolizable energy and SID lysine requirements for those sows, especially as you look at it from a parity to parity standpoint. And looking at that on a different format, if we look at the percentage of sows that have a set requirement on a group by group basis, their digestible lysine requirements increase as you move throughout gestation. So we can see that the digestible lysine requirement of multiparous and primiparous sows increase as gestation progresses from week 1 to 11 to weeks 12 through 17, but they increase at a different rate for primiparous sows versus multiparous sows. And that would allow some opportunities in precision feeding if we could alter the diet at different stages of gestation through phase feeding or diet blending. One of the most common things from an execution standpoint that I come across in gestation farms is overconditioned sows. Obviously, we want to avoid thin sows and underconditioned sows, but often the contrary is true in many operations where slat level employees and producers like to keep their sows a little extra conditioned. However, we need, from a nutritional standpoint, to recognize that overconditioned sows are costly. The obvious, easy economics to think about is wasted feed, but oftentimes we don't fully appreciate the effects of an overconditioned sow on her productivity and the subsequent lactation. And there are many reasons why we sometimes overfeed sows in gestation. Sometimes it's just a failure to calibrate box drops on gestation stalls, but in ESF farms where I often am spending more of my time, we may have not calibrated recently and made a dietary change when new byproduct feeds are available. Another situation is sometimes when we're feeding a whole pen via a competitive feeding strategy like stanchions or floor feeding, we sometimes have to overfeed the whole pen in order to keep the thinner sows or more timid sows in the pen in adequate body condition. And although there's been some major strides recently in using calipers and different measurements to understand a sow's body condition score, there's still many staff who are not properly trained or really understand how to score body condition of sows properly. There's a great study done by Malachy Young and others in 2004 that I reference often. And the most salient points are shown here at the bottom of this slide, where we can see the effect of increased back fat at farrowing on feed intake, back fat loss, and subsequent total born. And what the key takeaway is from this study was that fatter sows coming into lactation are going to eat less feed in lactation. They're going to lose a greater percentage of their body, their back fat reserves, and accordingly, on the subsequent reproductive cycle, they're going to have a lower number of total born. So the takeaway from this is we want to minimize the number of sows that are overfed in gestation. And this is one of these from idea to practice opportunities that precision feeding systems allow us to hit a higher percentage of sows at the ideal body condition. One of the things that I see in precision feeding systems, such as electronic sow feeding systems, is producers who maybe don't know how to capitalize on the ability of a feed system to alter the feeding strategy for a specific sow. So in a pen environment with electronic sow feeding systems, one of the recommendations that I have is to utilize feed curves such as early thin and late thin feed curves. The most common situation is to move sows into pens right after breeding or after preg check and do a body condition call at that time. And unfortunately, many times when we make that early body condition call, if we call the animal thin, for example, at 35 days of pregnancy, we put her on a thin curve that gives her excess feed for around 70 to 80 days of gestation and never go back and change that. And unfortunately, what can sometimes happen is those thin sows being fed at an excess of 25 to 50% of the sows that are on the average body condition curve end up becoming fat sows by the end of gestation. So you can see in the slide shown, the early thin curve shown here is a curve that can be automatically applied by many available ESF systems, where we can put that thin sow at day 35 on an excess amount of feed for, say, 30 days, where she might get 3.5 kilos instead of the 2.2 kilos that the average sow gets. But after 30 days, the system will automatically assume that she is back in average body condition and taper her back down to the ideal sow requirements. Now, obviously, some sows may still be thin and workers may need to adjust those sows, but the benefit of utilizing these early thin curves and late thin curves, as well as maybe an early fat curve, if you have a sow that's too fat in early gestation, is to minimize the amount of labor and human interventions that need to happen to hit a high percentage of sows at the right body condition. So this has been duly implemented by a lot of my customers as a way to get a higher percentage of sows in the right body condition throughout gestation while not wasting feed. Parity-specific diets is another topic that I'm pretty passionate about. Historically, in stall barns, we've had limitations on ability to feed different parities different diets, because typically in gestation stall barns, we've had one feed line hitting all the stalls, and we've had unknowns as far as where the different parity sows would be at, or where the gilts would be relative to the older sows. And then many times they aren't grouped by parity within stalls. However, as many parts of the world, especially in North America, transition to group housing for at least part of pregnancy, it opens up some new opportunities, because historically, when we're limited by feed lines or situations to feed only one diet in gestation, nutritionists err on the side of the animal within a population that has the highest nutrient requirements, which generally speaking is the gilt or P1 sow. And so by feeding to the gilt or P1 sow in most sow farms, we inherently overfeed some ingredients, especially amino acids, to older sows. And this does have a cost. And so with those younger sows having higher requirements, we want to make sure we hit those correctly. However, as we get into group housing situations where many times feeding group house sows by different parity also helps with aggression and managing sows that possibly could get beaten up by the older sows, many welfare recommendations encourage producers to separate young and older sows anyways from a pen management standpoint. Since we may have that where 50% of the sows are in some pens and 50% of the older sows are in another pen, it allows us to maybe think about this, especially in new construction or retrofit facilities, that we could design a barn where half of the pens are fed via one feed line and half of the pens are fed by another feed line, as a way to optimize the ability to feed a lower nutrient diet to older sows. And you can see that in the visual I have here. At the top, we have let's say a normal feeding system for group housing, where we have a tandem bin system feeding all of the pens the same diet. And at the bottom, we have a set of two tandem bin systems that now feed the different parity groups a different diet. One of the other advantages to this, at least with the system that I work with at Gestall, is that if we know the older sows are going to be always going to certain pens, they're already experienced with the feed station and require little to no training to utilize the station. So if the barn is designed to accommodate this, a producer can save money by using less stations overall, relative to the example at the top, where any sow could go anywhere. And so we need to plan on having, in this case, 4 stations per 60 head pen. So not only from an infrastructure standpoint, we can save some money, although we do have the cost of the extra set of bins, we can also save some money from a standpoint of not overfeeding those sows. And in the last economic models I ran, the opportunity to save money was around $5 Canadian for the older sows. And if we express this as about 50% of the sows in the herd that could be money saved, you could average about $2.50 Canadian per sow per year, which over a few years easily pays for the extra set of bins. And that doesn't even account for the fact that we're getting that management benefit of segregating those older aggressive sows from the young timid gilts and P1s who might be susceptible to reproductive challenges as a result. But to establish further the opportunities for precision feeding, I want to quickly go over some of the opportunities that precision feeding as it results in feed blending could offer. So when we talk about feed blending in many of these applications, we're usually talking about 2 feed lines that contain a low and a high nutrient density diet. And in this illustration, we have the high nutrient diet in red and the low nutrient diet in green, as illustrated by Dormad and others in 2017. For the parity 1 and the parity 2 and higher sows, we're going to use a different percentage of low and high feeds in order to accomplish the ability to feed them their nutrient requirements. And if we do something like this, no longer do we have to actually have different feed systems for different rows of pens. We would actually run a dual feed line over all of the pens. And then based on the sow's identity, when she's programmed into the pen, all you need to do is show the system that she's a parity 1 or a parity 2 or a parity 5, possibly body condition within that. And the system will automatically adjust the ratio of high and low feeds depending on her stage of pregnancy and her parity. The benefits of this is the ability to reduce about 25% of the protein content of certain stages of gestation when we would typically today overfeed protein, usually in early gestation. And we can also save money on lysine, and not to mention the ability to reduce the ammonia output of these sows. And in certain parts of the world, those ammonia outputs into the environment are becoming a bigger and bigger issue. So we simultaneously save money by using less feed, but also reduce the emissions of these sows into the environment. So when we're doing that type of precision feeding, using that high and low lysine diet or other nutrient diet, on the left, you can see the amount of sows whose needs are met when we're using precision feeding in this example. And a much higher percentage of sows' needs are met and not exceeded when we're using precision feeding. Whereas when you're using a single diet of feed, a single diet off to the right-hand side of this example, while there's still very few sows that actually experience a deficit of lysine or nutrient content, there's a lot higher percentage of sows that are fed in excess of their protein supplies of over 20%. And so that's where we're saving that by just programming the feeder to adjust that high and low nutrient diet depending on the stage of gestation. Switching gears off of the feed blending equation, there are also opportunities by using multiple feed lines to incorporate short-term feed additives. This has long been an opportunity area for gestating sows, and there's certain products that have been on the market for decades that historically have had a hard time penetrating the market because execution was always difficult with these short-term feed additives, because producers would have to top dress them at certain stages of gestation, and the extra labor and variation that goes with that typically limited their success in application. But several different products that have shown promise when used strategically at certain stages of gestation include omega-3s. There's been some Australian data by Schmitz and others in 2010 that showed that feeding fish oil in early gestation was able to increase number born alive by almost an entire piglet. And it also improved embryo survival the most in older sows. And that's where omega-3s have been shown to have the most potential benefit, is on embryo survival. Also, supplemental folate and vitamin B12, when fed for the first 30 to 60 days of pregnancy, have been shown to reduce the significance of early pregnancy loss, as well as betaine. Betane's long been used in certain areas of the world to offset the impact of heat stress, but in many cases, we may not need to feed betaine continuously, but only on certain days or periods of time when the temperature reaches a certain level. So being able to incorporate betaine strategically without having to feed it all or nothing may offer some opportunities to increase the utilization of that ingredient and also save costs for producers who don't want to feed it continuously. Other opportunities include the possibility of administering oral medications to specific animals. So feedback delivery for viral exposure is certainly an area of interest when we're inoculating sows for PRRS, but also when sows are initially introduced to the pen and we have lame or sick animals after initial mixing aggression. There's been interest in using NSAIDs or other anti-inflammatory drugs for short-term application to specific animals. It's much more preferable to be able to incorporate that in the feed as compared to going out and having to manually treat those animals. So that's definitely an opportunity area for short-term feed additives. And some of the feeding systems that exist today with feed blending can blend more than 2 diets or blend 2 diets as well as dosing a small amount of a third diet. So those are some specific short-term feed additives that are examples, but I'm sure I'm missing some, and nutritionists that are in the audience could easily add some other opportunity areas that may be of interest. As we switch to lactation feeding, I think lactation precision feeding is one of the biggest area of opportunities, especially when we look at the economics. Now, feed blending capabilities, as pictured in the bottom right of this slide, have only recently become available by limited amount of suppliers for lactation. But we've long known in the nutrition community that sows' amino acids and energy requirements vary wildly throughout lactation, not just from a parity standpoint, but by week or by day of lactation, and especially depending on the number of pigs nursed. Sows currently have to meet their requirements by adjusting their daily intake. But some sows are not able to meet their requirements because of their intake capacity, such as gilts or P1s, whereas in other cases, a lot of older sows overconsume. And so based on having to feed a single diet, we oftentimes are allowing those older sows to consume a lot higher concentration of nutrients than they typically require. So both parity and stage of lactation currently yield some wasted nutrients because we overfeed many sows. That's where blending a high and low lysine or amino acid diet may offer some productivity benefits or diet cost savings, just like we talked about in gestation. What's even more exciting is the capability of technology such as that pictured here to auto-adjust nutrient concentrations of sows who are deviating from their expected intake. This is particularly exciting because any of these technology applications need to be ergonomic in the farm. We can't expect slat level employees to have to go and change and adjust every sow daily. One of the opportunities of these technologies is to not have to get up every sow every day and investigate whether she's eating or healthy. If we have a system that's giving automatic feedback on whether the sow's getting up and meeting her expected intake requirements, which are going to vary a lot based on sow and day of lactation, the system can automatically flag sows that need to be checked. And if we're using feed blending and we know a sow is deviating from her expected intake, the system can automatically adjust the high-low ratio of diets in order to be closer to her actual nutrient requirement, even if she deviates from the average P1 on day 7, for example. Now, that being said, there's a lot of nuance to blending these diets right. And we need to invest in additional research at the university level and at the commercial research level to determine how to maximize the value of this technology. But from many models that have been done, the average savings over a 21-day lactation has typically ranged from about $7 Canadian for a P1 animal up to about $12 Canadian for a multi-pair sow. And those are just using U.S. diet costs, which are more available to me. But in many parts of Canada, especially, diet costs are going to be higher than down here in the United States. And so those dollar value savings per lactation can be quite a bit higher. When we also think about the fact that we have many farms that are now going to longer lactations or utilizing transition diets, with longer lactations, we're going to have more sows at that high level of intake for a longer period of time. Those are additional days where diet savings could really be utilized and capitalized on. So if we look at other things besides precision feeding, just management opportunities with feeding systems today offer some new opportunities. Prior to farrowing, there's currently a lot of industry variation on how we feed those sows when they come into farrowing. But recent data suggests that in many cases, the best results is to provide full feed or a higher amount of feed than we fed in gestation to start to adjust that sow early to give her more intake. However, in research from Cools and others and DeCalloway and others in 2014, they showed that overconditioned sows did not benefit from that full feed prior to farrowing, and in fact, that exacerbated their overconditioned problems. However, many systems still restrict feed prior to farrowing on these sows in order to prevent that post-farrowing feed crash. And so by using a technological feeder, we can easily apply different standards to different sows based on condition or other status. But one of the most exciting things that's been recently taking storm, at least in North America, is the frequency of feeding prior to farrowing and its impact on stillbirths. Fiera and others at the University of Aarhus have done a lot of research, and there's been recently published research by Gorley and others, as well as a group from AMBC, that has shown that feeding multiple meals per day prior to farrowing, not necessarily more feed, but spreading out the 5, 6, 8 pounds that a sow receives over multiple meals, speeds up the duration of her farrowing process and inherently decreases the amount of stillborns that sow yields. And it's typically thought that it's helping her with energy to complete the farrowing process. So many systems are looking at ways on how to feed those sows 2, 3, 4 times prior to farrowing per day. With electronic feeders, you can do that easily with no additional labor, whereas in a traditional format, we're going to need to use some form of labor or a modified system in order to accomplish that. But Other things within lactation that, from a management standpoint, offer some opportunity include varying opinions on whether to full feed or restrict sows in early lactation. And electronic precision feeders can help guide farms on what's best for their sows and their systems, because I come across a lot of different opinions and different feeding strategies. And by offering electronic sow feeders within and precision feeding opportunities in lactation, farms and systems can investigate this for themselves within a commercial environment and determine the payback potential for that different strategy. Wet dry feeding is a huge opportunity in many parts of the world. It's well known that wet dry feeding and lactation, as published by Bussières and others, can increase average daily feed intake by 7 to 10%. And in Canada, this is fairly common, but down here in the United States, many people are hesitant to practice wet dry feeding because of worries over labor and bull hygiene concerns. Automated delivery systems can prevent the sow from wasting feed and getting an accumulation of feed and water, and this can keep the feed fresh, but still generate the benefit in feed intake that wet dry feeding is typically known to yield. I think one of the most important things for producers and decision makers to think about is that these type of electronic sow feeders, and there's multiple different technologies available, allow for controlled feeding. But controlled feeding doesn't have to be the same as restricted feeding. Many production systems are so focused on the fact that we've got to keep feed in front of these sows at all times, which I agree with. But using some of these different feeding mechanisms, we can accomplish ad lib feeding and motivate those sows to eat with stimulation, but also minimize wastage and bowl cleaning and some of the downsides to the way we feed sows today in many farms. Here's a nice graph from the Fire and other paper about the improvement in time from last meal until farrowing. When we feed those sows more frequently throughout the day, we were able to reduce the farrowing length if she'd consumed feed within 4 hours of her onset of farrowing. Just to go into deeper detail on precision feeding and lactation, here's some information on the individual variability of nutrient requirements in lactating sows, as published by Gauthier and others in 2019. They looked at 2 different farms that had different farrowing performance, as can be seen from the chart here. Sows that averaged a different number in back fat prior to farrowing, sows that had different levels of feed intake, but I would say in general pretty good feed intake compared to what I see often in the United States, and 2 different lactation lengths, 18 versus 25 days, and a little bit of difference in number of piglets nursed and litter weight gain. They used the data from these 2 farms in order to model the variability and nutrient requirements of those lactating sows over a total of 2,500 records. So you can see, based on litter growth and the energy requirements, the feed intake of those sows per day when modeled to over energy balance showed a wide variation, especially on farm B, of the sow's energy balance as she progressed throughout lactation relating to her feed intake. And a very high percentage of those sows that were eating only 3, 4, 5, 6 kilos per day of feed, despite having generally the right diet requirements on average, many of those sows were at a negative energy balance for a long portion of their lactation. If we look at that when it comes to protein and lysine requirements, the same type of application was applied by Gauthier and others in 2019. And we can see that the SID lysine requirement of those sows on a grams per kilogram basis varies widely depending on the litter growth of those piglets. And based on that, the effect on the distribution of SID lysine requirements varied as well, where the optimal lysine concentration on a grams per kilogram basis was higher, especially for those sows on farm A as compared to farm B because of their lower feed intake. So thinking about precision feeding and how it provides the opportunity for a higher percentage of lactating sows to meet their requirements, I think this illustration from Dormad and others in 2019 really illustrates this well. So off to the left, you have a chart showing at a SID lysine level of 8.5 grams per kilogram fed a single diet throughout lactation. We can see that about 60 to 70% of the sows are fed in excess of 10% greater lysine than they need per day of lactation. and about 20 to 25% of sows are fed a deficit of 10% or more of their lysine requirements throughout lactation. If we're able to use two different diets for precision feeding, using feed blending or some other type of multi-phase feeding in lactation, we can minimize the number of sows that are either fed in excess or in deficit of those levels, and a very high percentage of sows fed within 5% plus or minus of their actual requirements per stage of lactation. This is where we're capturing that additional value, not only from reproductive status on those sows that were typically fed a deficit, but economically, we're saving a lot of money on lysine if we can reduce the amount fed for a lot of those sows that are at high intake levels or multi-para sows in late lactation whose requirements are not as high. So when we look at how those can be modeled over this group of sows, feeding either a single diet of 8.5 grams per kilogram of lysine or a blend of 4.8 or 10.5 grams per kilogram of lysine, we can reduce the number of sows adequately fed, or we can increase the number of sows adequately fed from 12% up to 83% just by using a precision feeding regimen in those two diets. And one of the other side benefits of this, especially in certain parts of the world, would find it valuable, is just a decrease in overall nitrogen intake and about a 10% decrease in nitrogen excretion, which may be in the future incentivized in certain parts of the world. So I think I've covered gestation and lactation opportunities and how we can reach both some short-term advantages and also maybe some long-term advantages by incorporating precision feeding. But I want to switch to growing pigs and the subpopulation of animals within the growing pig sector that I think is typically the most underfed or undermanaged is sows in on-site gilt development units, or gilts on on-site gilt development units. Part of the problem here, at least in North America, is that on-site gilt development units are usually kind of an afterthought when sow farms are being built, and they're often rarely updated or modified. But a picture off to the right shows a normal approach to on-site GDU design where we have usually 2 or 3 feed lines and animals that are staged at different pens based on their stocking density. They're typically fed ad libitum and given feed access until they're moved to breeding stalls after heat no service. This functions, but it doesn't necessarily meet the requirements of what we would do if they were even a grow finish animal where they could be fed a multi-phase diet. So one of the reasons that this provides an opportunity is National Pork Board recently commissioned a large study to see if gilt body composition could be altered by feeding diets that differed in metabolizable energy or amino acid concentrations. They polled U.S. industry and adjusted diets to 10% lower in metabolizable energy and 15% lower in SID lysine, just to see if they could impact the age at puberty or ovulation rate or reproductive tract development by modifying those diets. And when they did that, one of the most important takeaways from this trial was that around 50% of the gilts that were on trial were heavier at breeding than published and accepted target weight ranges at breeding of 135 to 150 kilos. And so one of the main takeaways from this study was that overweight gilts at breeding really present a risk to lifetime productivity. And the authors concluded that limit feeding may be needed in order to prevent excess body weight at breeding. Well, limit feeding is something that doesn't really match up very nicely with how we have most of these on-site gilt development units set up. But if there's an opportunity, we can certainly appreciate that sow turnover rates and death rates, replacement rates on farms today are higher than ever before and concerningly high in many parts of the world. So if we can manage these sows differently in the GDU phases and also save some money from an economic standpoint by keeping those animals at the right stage of growth, while not restricting them to the point that it impacts their first breeding, we have some opportunity there to hopefully improve lifetime longevity, as well as save some money on replacement gilt costs, as well as maintenance costs of sows once they enter gestation. So I encourage producers to revisit with their nutritionist possible opportunities to limit feeds gilts in the GDU. And that may require something as simple as the picture off to the far right, where we have a fence line feeding situation. But Also, opportunities might include things like precision feeders in the GDU phase, which I'll show some pictures in just a bit. But the GDU design challenges that exist today really exist because of that continuous flow system that exists in on-site GDUs, not an all-in, all-out system like grow finish. So we've got to find a way to balance the cost benefit of phase feeding these gilts against the investment in additional feed lines. One of the problems that I see is that nutritionists often get to provide limited input on how these GDUs are designed, and feed mill limitations often apply some pressure on the number of diets we can feed to small groups of gilts, as well as the ability to incorporate special ingredients in these gilt diets, such as sow VTMs, which could be beneficial to incorporate early in these gilts' life, especially for feet and leg health. Not to mention the fact that additional feed lines and systems typically require additional animal movement, which increases labor, which is at a premium in most systems today. Plus, those additional feed lines and systems increase the risk of feed budgeting and bin delivery mistakes. And so, as a result, again, we oftentimes simplify these gilt diets ad nauseum to the point we probably limit the ability to feed them very well. So one of the opportunities that I'd like to offer is that blending multiple diets in GDU phase can achieve some of the same benefits that I've already talked about in gestation and lactation. Simply running a dual feed line over all of the pens in a GDU allows the opportunity to use two extreme diets, possibly your first grower stage diet and your last finishing stage diet, and blend that according to those gilts' age. And this offers some opportunities where we wouldn't have to move those animals. A higher percentage of the gilts receive the right nutrients at the right time, and we can feed an unlimited number of phases and incorporate supplemental vitamins and trace minerals earlier in the gilt's life. Not to mention the fact that we can simplify feed mill demands because feed delivery drivers are always going to deliver the same two diets to the same two bins, reducing the risk of those delivery errors and feed budgeting mistakes. Now, if we can bring the feed to the gilts, maybe that changes the way we stock gilts in those pens if we can prevent the need to relocate them. This also offers some flexibility during new farm startups and herd closures, and it allows management to remotely access feed intake data, just like in lactation and gestation. And if they need to make a strategy change due to diet availability, we can do so immediately. Finally, I think from a labor standpoint, one of the things that's going to be really important going forward is accountability for out-of-feed events. And that's part of the reason why having the ability to visually see the actual intake is something that will help acknowledge if there's out-of-feed events such as feed outages or bin bridging. We can recognize it and find ways to address it. I won't spend much time today on grow finish precision feeding, as I think in general we do a pretty good job feeding, growing, and finishing animals in most cases. However, there are some benefits to precision feeding using feed blending technologies like I've talked about today, and that can be seen in the top left, where instead of feeding the dotted line phase feeding that we typically do in most finishing scenarios, we can actually feed these animals on a multi-phase feeding system where the diets are blended a different ratio daily. And research that I published in 2014 showed a slight benefit in feed efficiency, and research from the early 2000s by Vanderpeet Schwering and others showed a major reduction in nutrient excretion, which is part of the reason why there'd be a lot of interest in this in certain parts of the world where that nutrient excretion factor is going to be a big play. I think one of the other opportunities that may exist for precision feeding in grow finish is the ability to feed pens different diets or different blends specific to their situation. So sick pens or gilt barrow pens that could be split sex feeding may offer some major diet savings if we have the technology available to feed them a different diet. We also can look at opportunities for feeding pigs individually in the future. And I think in 5-10 years, the ability to really feed the individual pig a diet that's tailored to his opportunity may be valuable enough to pursue. So with that, I'll move on, but I think I hopefully have outlined some of the big opportunities that exist out there from a precision feeding standpoint in gestation, lactation, GDU, and grow finish. But I'll end on this and say that from idea to practice is the title of my slide. And while there's a lot of opportunities for this, we still need to work together as a group, both as nutritionists, veterinarians, slat level employees, to accomplish our goals. this is a slide from a customer of mine that was having trouble with feed outages. And you can see based on the blue lines per day of the year, there were many feed outages in gestation, which really impacted the productivity of this farm and the welfare of these sows. And so this is what I talked about on accountability of out of feed events. We still got a lot of work to do first in getting the feed to the animals, to the right animals at the right time. But some of the newly available technologies for precision feeding give us not only the ability to individually feed animals closer to their requirements, but also to reduce feed cost and also to increase the accountability and the ability to manage those animals from a distance or by managers who can't necessarily interact with every sow on large farms today. These type of technologies are going to be really valuable moving forward to move the needle of technology and precision in these modern sow farms and grow finish operations. So with that, I'd like to thank you guys for your time. I look forward to the question and answer session, as I'm sure there's a lot of interesting follow-up to these type of ideas we've promoted today.
All right. Well, thank you, Hyatt. That was so much information that you put in such a small amount of time. It's really great to see, like, I think it's been like 10 years ago that we met in a small town in Indiana, and it's great to see what you've been working on since then. So we do have 3 questions right now, and just a reminder for people, if they want to put questions in, they can put that in the Q&A box. Please don't put it in the chat because I won't be able to see it there. So Hyatt, we'll just start with the questions that we have so far. So the first one, can Gestal manage the addition of a feed additive for a specific period in gestation along with managing the blend feeding with 2 diets?
Yeah, thanks, Miranda, and good to see you again too after so many years. So thanks for the question and the opportunity to speak this morning. As far as the Gestal system goes, we actually do offer the ability to blend a third top dress or third diet. In my experience, this is also going to add additional cost beyond the dual feed line concept, and it is an extra accessory required for the Gestal system. So while I think there may be some niche application for that, especially in research settings, I think from a commercial slat level standpoint, we need to kind of manage the opportunity with the cost and complexity. And I think in most cases, we should try to work with blending up to 2 diets or feeding one or the other diet. A small additional top dress is a technological capability, but I worry about execution at the slat level on it. So yes, but I'd caution people from going too far down that road just from a idea to practice standpoint.
Okay, that makes sense. Next question. When looking at blend feeding and gestation with the investment for the additional feed line plus the blend feeding system cost, what is the expected ROI if we only look at the potential feed cost saving?
Yeah, great question. And I obviously get this quite a bit too. So I'd start by saying it's going to depend on where you're located a little bit. Based down here in the Midwestern US, where usually feed costs are pretty reasonable. I would say that ROI is going to be longer than somewhere where we have feed scarcity. Canada in general, I would say feed costs are typically higher. European diets are going to be higher. China, of course, diets are higher right now. So that ROI is going to vary a little bit. But the last time that I looked at it on a US basis, based on some of the models that I've run using the INRA model and the expected reduction in feed costs with US diet costs, we were running somewhere between 4 and 6 year payback on diet cost savings alone when you account for the Gestal equipment or something equivalent to that, as well as the extra feed line and feed bins. So not an immediate payback, but I think something that still pencils when you think about the life expectancy of a barn and the equipment in the barn. The question really that needs to get more fleshed out, I think, at the academic level from a research standpoint is what can we glean from this beyond feed savings alone? I think, because this is new technology that really has only been available on the market for the past couple of years, there's a lot of questions because it's a completely new frontier in how to feed sows and lactation. And there's an opportunity for a lot of research to answer some pretty interesting questions with some different applications. And I'm excited to be a part of some of that research. And I know some of it's going to be led without necessarily me involved, but I'm excited to see where that goes because I frankly am unsure of the magnitude of response there I think it's going to depend a lot on situation such as wean age and the diversity of the population of the sows within a given farm.
Okay. Then the next question, do you have any study that show the impact of sow performance when better feeding the sow in gestation with a precision feeding approach?
Yeah, myself, no, I haven't done any research that's published, at least at the gestall level, with blend feeding in gestation. There's quite a few studies that have been done looking at some different phase feeding approaches. And that's part of the reason why I would say, based on the literature available, I think one of the biggest opportunities is not so much feed blending throughout gestation, but I think having the ability to feed a different diet at a different stage of gestation. There appears to be stronger research, especially internationally, on feeding a different diet in early gestation as compared to mid and late gestation. And then there's been some recent diet with the increased interest in transition diets. There's been some research that's been published about, for example, bringing in a lactation diet for the last week to 2 weeks or a bit longer in gestation to kind of serve as a transition diet, which also adds supplemental amino acids and proteins. So I think there's some benefit there when we just think about a discrete change, and additional research is needed when we look at feed blending, because that does offer some opportunities for things like maybe changing the amino acid pattern. But again, these are some questions that are only now getting to be able to be asked. And so there's some research out of Ron Ball's group in Canada, as well as some coming out of South Dakota State University that are looking at precision feeding, blending in gestation, and I think coming up with some good data. But we need to continue to reinforce that with more published work on larger data sets before I'm confident in saying that payback is immediately there.
Okay, sounds good. Looks like we're out of time, so thank you very much for your presentation.
Thank you.